Okay, welcome back to Elements Calculus 2. Okay, I think I got the sound on now. We'll check. But what we're going to be looking for is using Taylor polynomials, determine the area bounded by e to the square root of x between the x-axis between x equals 0 and x equals 1. We put your answer to 4 decimal places. Okay, so here's what we're going to be dealing with. Again, we still want to keep between x, we still want to evaluate this thing at x equals 0. So what we're looking for is let me go ahead and have a look at, we have a Taylor polynomial that looks like we want e to the square root of x. And really what we do is this, 0 to 1, right? This is what we're actually asking you to do. But there is no u substitution we can do here. There is no actual integral that we have. Like there's no u substitution. There's nothing to help us break this integral so we can actually do it. There's nothing I can actually do here. So what we do is we say, you know what? We're going to use Taylor polynomials to approximate this e to the square root of x as a polynomial and then integrate this thing. Okay. So looking back, e to the u is equal to, okay, as a Taylor polynomial, we'll go back and we'll say, okay, again, you have a table. Okay. You have a table, and I'm looking for the e to the x one. It's 1 plus x squared over 2 plus x squared over 3 factorial plus dot, dot, dot. So let's go up here. We'll say we've got 1 plus u squared over 2 plus u cubed over 6, that's 3 factorial, plus u to the fourth over 4 factorial, which would be 24. Okay. Now, what u is actually going to be, we're going to say let u equal the square root of x. So that's what we really have here. So I'm going to say that e to the square root of x is equal to 1 plus the square root of x plus the square root of x squared. That's just going to be x over 2 plus x to the what? To the 3 halves over 6 plus x to the 4 halves. Okay, better known as 2 over 24. So let's go ahead and say this is equal to 1 plus the square root of x. Actually, let's keep it as a calculus problem. Okay. Let's keep this as a calculus problem and say this is x to the 1 half. Okay, plus 1 half x to the 1 plus 1/6 x to the 3 halves plus 1 over 24 x to the fourth. Okay. I'm sorry, squared. It's going to be squared. 4 halves. Okay, it's going to be squared. There we go. Squared. Okay, and we wanted to integrate this thing between 0 and 1. See how much easier the integral this is? Like we can all do this. We are all good at integrating polynomials. We just have to do this. Okay, so this is our Taylor series. We've in terms of u, we know that x is any real number that it'll work out. Okay, so we're going to say that we just integrate this. This is just going to be x plus x to the 1 half plus 1. We're going to have a 3 halves. Let's go ahead and say 3 halves. 2/3 here, 3 plus 1 half. And we have x squared over 2. Okay, plus 1/6 x to the, we're going to add 1 to this. So we have 3 halves. We're going to have 5 halves. We need a 2/5 here. Okay, plus 1/24 x3 over 3. Okay, let's clean this up a little bit. So we just have x plus 2/3 x to the 3 halves plus 1/4 x squared plus, let's say 2 over 30 x to the 5 halves plus 3 times 24 is going to be 1 over 72 x to the 3 here. And we're just going to evaluate this between 0 and 1. Conveniently, when x equals 0, all of this is 0, so we don't have to worry about that. We just plug in a 1. So we're just going to approximate this area as 1 plus 2/3, okay, times 1, plus 1/4 times 1, plus 1/15, that would be 2/30ths, plus 1 over 72. And then we're just going to use our calculators to go ahead and do this. I would not recommend doing that, but my calculator has an A, what is this? A, B over C button. If you press this button, it lets you type in fractions. It also lets you reduce fractions. So we're just going to go ahead and do that. And we'll just say, okay, this is 1 plus 2/3. Okay, and you just have to trust me that I'm doing this, plus 1/4. Okay, plus 1/15, plus 1/72, and say equals. And what did it give me? It gave me, I'll give you both answers here. We have 719 over 360. I'm sure that's delightful. And we'll just go ahead and say that is equal to. And I got 1.997. Okay. To 4 decimal places. So that would be our answer for this thing. If you're wondering, like, what was I expecting people to do for this problem? This is what I was expecting you to do for the problem. Look at the table that was given to you. Use the table that was given to you to recast the Taylor series to the problem that you have. I do not want you on these problems. I do not want you to go ahead and recalculate a Taylor series. Okay, sometimes what I ask you for is harder than what you think it is. Sometimes it's easier than what you think it is. In this case, I think it's easier than what people would come across and try to do this. But this is the kind of thing I'm looking for, is for you to approximate this horrible integral, which you can't do with a Taylor series, and do it that way. I guess alternatively, we could have go from 0 to 1, divided into a bunch of points, and then use Simpson's rule and done exactly the same thing for Simpson's rule to get an area to approximate it as well. Someday that might be a nice numerical methods kind of a project, but that's way too much for a test, and that's a little bit long. But that's how you use this stuff in real life. Okay, thank you very much for watching. Now that we have sound, and good luck with the test, everybody, and take care. So stop and